In this video, I'm going to show you how to quickly graph the three basic functions of trigonometry. So let's start with y is equals to sine of x. And here I made a unit circle. And what I want you to remember are the coordinates of the unit circle. Remember, this is 1, 0. This is negative 1, 0. This is 0, negative 1. And this is 0, 1. And remember, these ones have a meaning. And the meaning we attach to this is very important. So the first coordinate here, the x, represents the cosine. And the second one represents the sine. For example, the cosine of 0 degrees or 0 radians is 1, and the cosine of 2 pi radians is equals to 1, or the cosine of 0 degrees is 1, and the sine of 0 degrees is 0, like you can see here. So I'm going to, look at those coordinates, remember that. So when I go to graphing, I will start with sine of 0. Remember, I am looking at I focus on the y coordinate. So the sine of 0 is 0. So I'm going to put 0 right there. And then the cosine of 90 degrees, the sine of 90 degrees, which is going to be 1. So I come here and look for half of pi. So that's going to be 1. Then the next one for pi, the sine is the second coordinate. It's going to be 0. And now I can see how the pattern is. So that means the next one is going to 70 degrees. Is going to be negative 1. 2 pi is going to be 0 again. And I can even go to this side and do the same because I see the pattern. Now I can just continue. This is going to be 1 and this is going to be 0. And then the next thing is just to connect those points with a smooth curve. And remember, it just keeps going. So here we are now going to, it just keeps going. So what we are going to focus on here are some basic things you need to know about this function. So for example, the domain, you can see it starts from negative infinity and it keeps going to infinity. So you can see the zeros are at every integer, 0 pi, so 1 pi, 2 pi. So it is at pi, n, or n pi, maybe I should write n pi or k pi, and n here is an integer. So that means it is at 0 pi, 1 pi, 2 pi, or even the negative integers. The amplitude is the highest or the lowest the function goes. And actually when it's the distance. Amplitude is the distance from the mid-low line. So we call this the mid line. So the amplitude is the distance from the midline to the maximum point. And this is the maximum point right here. And so that is the amplitude. I'm going to represent it with A. So A is equals to 1 in this case. And it is the absolute value because it represents the distance. Now the next thing I want us to look at is the period. And the period is from, you can see this graph represents the same thing which is being repeated over and over. For example, if I start at 0, I can pick any starting point. If I start at 0 and I see it keeps going up, goes down, then it is going up again. So see that part of the graph represents one cycle. This graph has many cycles, just repeated. So that is one period. And you can see this period corresponds to the distance from 0 to 2 pi. So the period is going to be 2 pi. And you can also look at the other side. Here, from this point here to this point here. So here it's going up, and here it's going up again. So that is the period of 2 pi. And here we can see the range. I forgot to write the range. It's from negative pi to pi, negative 1 to 1. Okay, now let's look at the cosine. And when you look at the cosine function, again we are going to remember the coordinates 1, 0, negative 1, 0. This is 0, negative 1, and 1, 0, 1. Remember, this represents the cosine, this represents the sine. So now we are going to focus on the x coordinate. So the cosine of 0 is 1. The cosine of 90 degrees is 0. The cosine of 180 degrees is negative 1. The cosine of 270 is 0. The cosine of 360 is going to be 1. So here I can continue with this pattern. So that's going to be 0. That's going to be negative 1. This one is going to be 0. And this one is going to be positive 1. And now all I need is to connect my points with a smooth curve. And that is the cosine function. And let's look at the basics of the cosine function. So here I can see the domain is from negative infinity to infinity. The range is from negative 1 to 1. I can see the zeros are at pi over 2. So the first 0 is at pi over 2 plus every 1 pi plus pi plus n pi plus n pi. So plus 1 pi, like 1.5 pi. So see this is 1.5 pi. So every pi over 2 and n pi. The amplitude, remember, is the distance from the middle line to the maximum point. So this is the amplitude. So this is going to be the amplitude, which is the absolute value, which is equals to 1. And the period, I'm going to look at my graph. So this is at 0, it is at 1, and it's coming from down, going up, then down. So at this other point, this is when the same cycle is going to repeat. So that's the period, and you can see the period is equals to 2 pi. And something maybe I should mention here about the amplitude, because sometimes you're not going to have the graph. The amplitude is also given by maximum value minus minimum value divided by 2. So you can always use that formula to find the amplitude. And so there is the cosine function. Okay. Here is the tan function. So here remember the coordinates 1, 0, negative 1, 0, 0, 1, negative 1, 0. And remember, when I do the tan is has some more work than the others, because I have to remember that tan of theta is given by sine of theta over cosine of theta. So what I'm going to do because this is not directly given from the unit circle, I'm going to find it. So remember, this is cosine, this is sine. So I'm going to start by finding the tangent here. So the tangent here is going to be 1 is given by sine over cosine. So 0 over 1, which is equals to 0. So that is the tan value. Let me find the tan value for this angle here. It's going to be t, I'm just going to use t value is going to be given by 1 divided by 0. And remember, that is going to be undefined. Then I go to this one here. The tan is going to be given, tan of pi is going to be given by the tan of pi. Let me just write it well. Tan of pi is going to be given by 0 divided by 1, which is 0. And finally, this one is going to be 0 over -1, which is going to be undefined. And let me just circle those values so that we can see them. So I want to be able to see those values. So see, this one is undefined. So this is 0, undefined, and 0. Okay, so now what I'm going to do here, before I start graphing, I'm going to look at the undefined values. What does it mean? The graph is not good, can never be that value. And if you remember, a line which is being approached, this line is going to be approached, but it's never going to be touched. So because 10 can never be that value. So this graph is undefined at pi over 2. So I'm going to, at pi over 2, I'm going to show that with a dashed line. So that's going to be an asymptote. And then it's also going to be undefined at -pi over 2. And I'm going to continue after every pi, I'm going to repeat the same thing. So those are the asymptotes. And then, okay, so let me do one more here. And then I'm going to graph the function. So tan of 0 is 0, and tan of 180 is 0, and 2 pi is 0. So all these are zeros. And then all I need to do, I need to connect them. See, this line is going to be approached, but it's never going to be touched. So this is how the graph is going to look like. See, this is way different from the other two. Okay, so and I can do one more, and I'm not going to do any other. And you can see here, so here I'm going to focus on the range. See here, the range is from -infinity to infinity, and you can see the amplitude is none, and the period, this cycle repeats every pi. You can see that's different from the other graphs. The cycle repeats every pi, and maybe I can write the zeros. The zeros are at pi and pi. Every integer, that's a 0, and I'm just going to stop there. So that's how to graph the three basic